Hello, my name is Soygür and today I will present you my term project for EEE 519 Power Electronics course. For the course, we were asked to design a flyback converter that would convert 220 volts AC to 12 volts DC. Before going on with the details of my project, I would like to perform a short demonstration. This PCB is my flyback converter. At its output, 47 ohms of load is connected, and when I connect the line voltage to the input, I expect to see 12 volts DC at the output. So at the output, you see that the circuit works, and the power meter measures the power consumption. Now I will present you the details of my project. The project requirements are explained in detail below. As I mentioned before, we are asked to design and implement a flyback converter that converts line voltage to 12 volt DC using the switching IC LNK562. The project is divided into three parts. In the first part, we perform the theoretical design, decide on the component parameters, and run LT-SPICE simulations to verify our design. In the second part, we draw the schematic and PCB layout using the trace software. And in the third part, we receive our actual PCBs, solder the components on them, wind our transformers, and run tests on our finalized flyback converters. The first part includes many design steps that I tried to summarize here. I began by designing the snubber network, then moved on to deciding the transformer parameters. Then I provided an output sampler circuitry that would provide feedback to the switching IC. And for the input circuitry, I decided to use a half-wave rectifier at the input. The schematic demonstrates my flyback converter in detail. This is the LT-SPICE schematic that I used for my simulations that shows the whole circuit in detail. And then in part 2, I drew that schematic in dip trace by using the actual component list provided to us. And this is the bill of materials that shows the list of components that I used in my converter. And this is the top layer layout of the PCB generated by dip trace that shows the component placements. The bottom layer layout, on the other hand, shows the routings throughout the PCB. In the third part, I began by winding my transformer and running tests on it using the RLC meter. Then I soldered all components on my PCB and completed my flyback converter and ran tests on it using the DC and AC power supplies. I ran my final test using the actual line voltage, and I measured a maximum load power of 3 watts that provided 75% of efficiency. And the no-load power consumption was 0.5 watts. Thank you for watching.